HSEB 2064, question number 3A. Group A, question number 3A. In an examination paper on a business math, 10 questions are set. In how many ways can you choose 6 questions to answer? In an examination paper on business maths, 10 questions are set. In how many ways can you choose 6 questions to answer? Solution. So this is the problem related to combination. In the question we are given 10 questions. Total questions are 10 and we have to choose 6 questions out of 10. In how many ways can you choose 6 questions to answer? Let the total number of questions is 10, so we can suppose n is equal to 10. Total number of questions, we have to choose 6 questions out of 10. So let's suppose r is equal to 6, the number of questions to choose. The number of ways a student can choose 6 questions out of 10 questions is equal to what? So we can represent it by C10, 6. C10, 6. The selection of 6 questions out of 10 questions is equal to what? We know. Using the formula of combination, we know C and R is equal to n factorial by n minus r factorial into r factorial. C and R, that means the selection of r objects from the total objects n is given by the formula n factorial by n minus r factorial into r factorial. The value of n is 10. The value of n is 10 and the value of r is 6. That means C10, 6. Selection of 6 questions out of 10 is equal to the value of n is 10. So we can substitute n value 10 factorial by n minus r factorial. N means 10 and r is 6. So n minus r means 10 minus 6 factorial into r means the value of r is 6. So r factorial means 6 factorial. 10 factorial. 10 factorial will expand up to 6 factorial so that we can cancel. 10 factorial. 10 factorial means 10 into 9 into 8 into 7 into 6 factorial. 4 factorial means 4 into 3 into 2 into 1. 6 factorial as 6 is cancelled. So after putting the value of n, 10 factorial, the value of r 6. Then 10 factorial means 10 factorial. 10 minus 6 means 4 factorial. 6 factorial as it is. And expanding 10 factorial up to 6 factorial. So that 6 we can cancel with 6 factorial. 10 factorial means 10 into 9 into 8 into 7 into 6. 4 factorial means 4 into 3 into 2 into 1 into 6 factorial. Now 6 factorial will cancel. 4 to 8, so 8 cancel. Now 10 into 9 into 7, divide by 3. 10 into 9, 90, 90 into 7 by 3, 30 into 7, that means 210 ways. So according to the question, 6 questions out of 10, 6 questions out of total question 10, a student can choose in 210 ways. Therefore, the required number of ways is equal to 210 ways. Exam questions, solution 2064, HSEB 2064, question number 3B. Group A, question number 3B, if A is equal to 1, 3, 2, 1, if matrix A is equal to 1, 3, 2, 1, so that A square minus 2A minus 5I is equal to 0, where I and 0 are the 2 by 2 identity and 0 matrices respectively. Solution. In this problem, in this question, a matrix A is given 1, 3, 2, 1, and by using this matrix, we have to show that the value of A square minus 2A minus 5I is equal to 0. That means the value of the matrix A square minus 2A minus 5I is equal to 0, where 0 is null matrix and I is the identity matrix of order 2 by 2. Solution. A is equal to 1, 3, 2, 1. The matrix A is given equals to 1, 3, 2, 1. At first, we'll find out the value of A square. The matrix A is 1, 3, 2, 1. Therefore, A square is equal to A into A. The value of A is 1, 3, 2, 1 into the value of A is 1, 3, 2, 1. So we have to multiply matrix A with the matrix A itself. So according to the rule of multiplication of matrices, in order to multiply any two matrices, we have to multiply row with column. Row with column. So let's multiply first row and first column. Then we'll multiply first row and second column. Similarly, we'll follow the same step. We'll take the second row, multiply with the first column. Again, second row, multiply with the second column. So let's start multiplying by taking the first row. So first row we are going to multiply with the first column. So 1 into 1 plus 2 into 3. So we have to multiply first element with first element plus second element with second element. So 1 into 1 plus 2 into 3. Again we'll multiply first row and the first column. 1 into 2 plus 2 into 1. The same process will follow for multiplying by taking the second row. 3, 1 will multiply. The first row will multiply with the first column. Again, first row will multiply with the second column. So 3 into 1 plus 1 into 3. Again, 3 into 2 plus 1 into 1. Therefore, the value of A square is 1 into 1, 1, 2 3s are 6. 1 into 2, 2 plus 2 into 1, 2. 3 into 1, 3 plus 3 into 1, 3. 3 2 are 6 plus 1 into 1. 1 plus 6 7, 6 plus 2 2 plus 2 4, 3 plus 3 6, 6 plus 1 7. So this is the value of A square, multiplying the matrix A with the matrix A. Next we'll find the value of 2A, then the value of 5i. The value of matrix 2A is 2 into matrix A is equal to 2 into the value of matrix A is 1 3 2 1. So if we multiply matrix 1 3 2 1 by 2, then we'll get 2 1s are 2, 2 3s are 6, 2 2s are 4, and 2 1s are 2. So matrix 1 3 2 1 multiplying by 2, we'll get 2 6 4 2. The value of I means identity matrix. Identity matrix is 1 0 0 0 1. We have to find the value of A square minus 2A minus 5i. The value of A square is 7647 minus the value of 2A is 2642, and the value of 5i means 1001. So 7467 as it is minus 2642 as it is minus 5 into 1 5 0 as it is 500 5 into 1 5. 7 minus 2 5, 4 minus 4 0, 6 minus 6 0, 7 minus 2 5. So this is the difference of the first two matrix. The third matrix as it is. Now the first and second matrix both are equal. So the difference will be equal to 0 0 0. 5 minus 5, 0 minus 0, 0 minus 0, 5 minus 5. So we get 5 minus 5 0 0 0 0. Therefore the value of A square minus 2A is equal to minus 5i. All the elements are 0. So it is a null matrix, or we can say it is a 0 matrix. Hence the value of A square minus 2A minus 5i is equal to 0. Hence it is proved.